In 1958, a heavy transport aircraft came down short at Kalikat Creek, roughly 30 miles south of Galena, Alaska. Publicly available summaries identify the accident and the site, but they do not clearly establish the initiating failure. It was a bush-flying environment, far from the infrastructure of a major airport. The machine sustained significant damage during the rollout, but the primary hull remained structurally contiguous. The flight crew survived the impact event, but the aircraft was immediately grounded. This wrecked machine was a Consolidated LB-30 Liberator II. Specifically, it carried the original Royal Air Force serial AL-557. It was an early export variant of the heavy bomber that would later become famous as the American B-24. Delivered in October 1941, this specific airframe was the 55th Liberator built. That low production number makes it the second oldest known surviving Liberator in existence. It represents a crucial baseline of heavy bomber engineering constructed before wartime mass production significantly altered the design. By 1958, its military origins were far behind it. The aircraft was operating as a civilian freighter for the Morrison-Knudsen Company under the civilian registration N92MK. Its mission was strictly logistical, hauling heavy equipment and construction supplies for the distant early warning radar line across Alaska and Canada. Operating a massive 4-engine transport over the roadless Alaskan interior imposed severe operational constraints. Public summaries do not preserve enough detail to reconstruct the crew's route planning, fuel state, or diversion options. The forced landing created an immediate logistical boundary. The aircraft was resting in a location disconnected from road networks, marine ports, and heavy maintenance facilities. Returning a 4-engine transport to service from Kalikat Creek would have required tools, shelter, access, and part support that the available histories do not describe. Morrison-Knudsen's recorded course of action was simpler and harsher. Crews removed reusable components, including the 4 engines, navigation instruments, radios, and transportable mechanical hardware. That followed the standard logic of remote heavy aircraft salvage. Retrieve what can be carried out by hand or light aircraft, then leave the heavy airframe behind. Crews then pushed the gutted hull clear of the dirt strip so other bush flights could continue. The aircraft was officially abandoned on site, leaving the primary load-bearing structure, the wings, twin tail, and main fuselage, in place. The technical history of the airframe was suspended in place. Before any future recovery team could attempt extraction, it would have to determine what structural evidence remained in the dirt. The physical footprint of a heavy bomber is defined by its central structural volume. When a military airframe is modified for commercial cargo transport, that volume becomes the most important area of uncertainty. Cargo conversion can change how the fuselage carries stress, especially around the former bomb bay and center fuselage. But the public record does not support a precise claim that every internal bomb bay member was removed from this aircraft. Long before the 1958 forced landing, AL-557 had already been altered enough that its engineering baseline could no longer be treated as a clean wartime configuration. In 1945, Scottish Aviation took the former Royal Air Force bomber and converted it into a civilian passenger and freight transport. The objective was to make the military airframe useful in commercial service, not to preserve a combat layout. To achieve this, engineers modified the bomb bay and interior cargo areas, but the public record does not support a precise claim that every vertical bomb bay structure was completely removed. They also cut passenger windows into the fuselage and altered the nose for cargo access. The available photographs and captions support those visible changes, including a swing-opening nose and cargo hold conversion, but they do not document exactly which longerons or internal members were severed. The aircraft entered civilian service heavily modified, later flying under the name Maid of Athens for Hellenic Airlines. By the time the aircraft suffered its final accident in 1958, the Hellenic Airlines branding had been replaced. The twin vertical stabilizers bore the distinctive N92MK civilian registration in bold paint. That livery is strong visual evidence tying the wrecked hull to its final Morrison-Knudsen configuration. It confirms the aircraft's civilian identity at the end of its working life, while the exact internal state of every structural modification has to be treated more cautiously. When the aircraft came down at Kalikat Creek, The crew was flying a heavily modified civil transport, not an unaltered wartime bomber. During the accident sequence, the aircraft landed short at Kalikat Creek and sustained damage severe enough to end its service life. Public summaries do not establish whether the landing gear was extended, collapsed, or otherwise involved in the damage sequence, nor do they preserve a detailed engineering reconstruction of how impact loads move through the cargo floor or lower fuselage. The safer constraint is structural uncertainty. Passenger windows, cargo provisions, and nose changes are visible in the surviving record. Exact internal load path changes would require inspection against B-24 and LB-30 drawings. In the military configuration, B-24 technical material places the bomb bays in the center fuselage under the center wing section, so cargo conversion in that area matters. Without a project engineering report for AL-557, engineers examining the wrecked hull could not treat every deformation as crash damage or every surviving joint as original geometry. When the salvage crews departed the site, they left behind a stripped airframe whose original handling points and surviving attachment geometry had to be treated cautiously until inspected. Any future attempt to lift or move the aircraft risked twisting or secondary fracture if the loads were uncontrolled. Before any transport aircraft could fly the wreckage out of the remote bush, recovery crews would have to separate and support the major components with great restraint. How could engineers safely move an airframe whose true internal strength could no longer be assumed? 32 years is a critical time frame for exposed aluminum in a sub-Arctic environment. Between 1958 and 1990, the abandoned Liberator airframe remained static on the tundra at Kalikat Creek. During this 32-year window, the structure endured relentless freeze and thaw cycles, moisture intrusion, and shifting ground beneath its belly. The remote location served as a protective barrier against human interference, but the environmental exposure steadily weakened the remaining material. In 1990, the Alaska Aviation Heritage Museum initiated a formal field recovery operation to extract the historic bomber from the bush. The operational objective was to preserve the surviving identity of the aircraft, but the handling problem was severe. The public recovery history gives the essential fact. In 1990, the Alaska Aviation Heritage Museum acquired the aircraft, dismantled it, and flew it out in 2 C-133 loads to Anchorage. What it does not preserve is a bolt-by-bolt field procedure. The safest version is therefore procedural in broad strokes only. The team had to break the large airframe into transportable sections at Kalikat Creek, support the fragile assemblies during separation, and avoid adding new damage to an aircraft already altered by civil conversion and decades of exposure. The exact sequence of fasteners, pins, jacks, and production brakes remains undocumented in the public sources. The 1990 intervention successfully secured the major surviving components of the historical airframe. The Alaska Aviation Heritage Museum managed to dismantle and recover the heavy transport from the Alaskan bush, but the public record does not establish that the operation caused no secondary damage at all. However, separating the components was only the first phase of the logistical problem. The isolated wings, the tail, and the fuselage sections were still sitting on an improvised dirt strip completely disconnected from any modern road infrastructure. The extraction team now faced a massive transportation barrier. Once dismantled, how would these fragile bomber sections be moved across the impassable Alaskan bush? The extraction of heavy machinery from the bush dictates a rigid arithmetic of internal space. The recovery team had to fit the entire footprint of a dismantled heavy bomber into exactly 2 separate flight loads. This geometric limit defined the final phase of the 1990 intervention. The extraction vehicle was a Douglas C-133 Cargomaster. Public histories identify that aircraft type as the heavy lifter used to move AL-557 out of Kalikat Creek in 2 loads. It should not be described as the only possible asset without a supporting logistics record, but it clearly provided the capacity the recovery required. The Cargomaster was a large United States Air Force strategic transport, capable of carrying ballistic missiles and other oversized military cargo through rear and side loading doors, making it well suited to this kind of outsized recovery problem. Loading this aircraft introduced the real constraint of airlift geometry. The Cargomaster could provide the bridge out of the bush, but the components still had to fit through its cargo opening, sit within its internal envelope, and be secured for flight. The public record confirms the result, not the detailed loading plan. The dismantled aircraft was divided into two C-133 loads and flown to Anchorage. The exact order of the fuselage, wings, tail surfaces, and associated components within those two loads remains undocumented in the public summaries. The successful execution of the second flight load finalized the extraction phase. The Cargomaster provided the necessary mechanical bridge between the impassable tundra and modern aviation infrastructure. The extraction proved that disciplined geometric planning could overcome the physical impossibility of dragging a heavy bomber out of the bush. As the second heavy transport flight cleared the airspace over Kalikat Creek, the recovery team had successfully retrieved the historic airframe. Where would this massive inventory of heavy bomber components go to await reconstruction? The extraction operation successfully physically secured the historical asset from the Alaskan wilderness. The next custodial history was not a clean, immediate move into restoration. After the 1990 recovery to Anchorage, ownership later passed to the Lone Star Flight Museum in 1996, and the project was stored for many years at Vintage Aircraft in Fort Collins, Colorado. Don Whittington and Worldjet acquired it in 2001. By 2023, Project Warbird was hauling the majority of the bomber from Texas toward the Carolinas. The accurate point is not an exact 27-year stay in one exposed field, but a prolonged and complicated period of outdoor storage, ownership changes, and delayed restoration. Long-term outdoor storage still matters, even when the surviving metal is better than expected. Aircraft structures exposed to weather require careful corrosion inspection, treatment, and documentation, and this airframe also carried old civil modifications and localized damage. But the current restoration assessment is more optimistic than a narrative of advanced atmospheric decay. Project Warbird's public restoration update reports that the structure remains sound, with almost no corrosion noted, while some sections suffered from vandalism and required repair. The conservation challenge, then, is not a simple story of total environmental collapse. It is the slower work of inspection, selective reuse, and rebuilding a modified airframe back toward its wartime configuration. Could a heavily altered but surprisingly salvageable airframe ever be safely returned to its original engineering form? Reversing decades of environmental decay and commercial modification forces a strict engineering choice. When Project Warbird acquired the dismantled heavy bomber in 2023, the engineering team had to select a clear restoration pathway. They could stabilize the artifact in its current fragile condition for static display, or they could execute a complete structural rebuild to an airworthy configuration. The institutional decision was made to reconstruct the aircraft entirely to its original military specification. To execute this decision, the massive components required transport from storage and staging sites to the restoration network in the Carolinas. Project Warbird acquired the aircraft in 2023 and hauled the majority of the bomber from Texas toward South Carolina. The nose section first went to Hangar 13 in Asheville, North Carolina, where Ray Moore built a roll-around fixture for the forward fuselage. After that fixture work, the section moved down to Project Warbird's facility in Easley, South Carolina, where active restoration work began. The immediate priority was establishing a geometric baseline for the forward fuselage. Because the aircraft had suffered severe structural erasure from early commercial modifications, the restoration team inherited a shell missing its primary load paths. The original bomb bay trusses were completely absent. To support the sagging fuselage, engineers constructed a massive steel alignment jig. This rigid framework acts as an external skeleton, securing the deformed aluminum shell in exact three-dimensional space. The jig ensures that as new structural members are fitted, the airframe does not warp out of alignment. The restoration team must slowly rebuild the core integrity from the inside out, replacing the lost military baseline one frame at a time. Rebuilding this baseline requires patient archival engineering. The team is collecting technical manuals, drawings, parts, and surviving hardware, then checking the aircraft against the original Royal Air Force bomber configuration. Public sources do not confirm laser scanning of other airframes, nor do they establish that the entire original nose was completely discarded. What is supported is narrower and still demanding. The restoration must reverse passenger and cargo modifications, restore the bomber configuration, and rebuild missing or damaged structure using documented data wherever possible. The fabrication phase demands strict airworthy restoration discipline. Modern patches cannot simply be improvised over damaged areas if the aircraft is to fly. Missing or damaged skins, stringers, bulkheads, and braces have to be inspected, repaired, replaced, and documented using approved materials and methods appropriate to the type. Some original material may be reused if it passes inspection. Other pieces may have to be newly made. The goal is not just visual authenticity, but a documented structure capable of carrying flight loads safely. Sourcing the complex mechanical hardware for this specific bomber variant introduces another procedural boundary. Project Warbird engages in component sharing and parts tracing across a network of global restoration facilities. Rare mechanical actuators, landing gear components, and instrument panels must be located, verified, and overhauled. When original hardware is entirely unavailable, the facility must manufacture new components based strictly on the approved archival data. This process slowly transforms a hollowed-out cargo shell back into a rigid and functional bomber fuselage. The ongoing restoration in South Carolina represents the final phase of an extended recovery cycle. The engineering team is methodically correcting the geometric alterations and structural deficits accumulated over 80 years of civilian use, harsh abandonment, and static exposure. The ultimate goal is to produce a fully airworthy, consolidated LB-30 Liberator II, capable of flying on its own power. The intensive reconstruction process continues to document exactly how early manufacturing techniques were applied before mass wartime production standardized the global fleet. What will the final restored geometry reveal about the earliest days of heavy bomber design?